I want to invite Francois Chollet and Mike Knoop up to the stage right now, who are going to be doing a fireside chat.
Thank you, Greg. Great kickoff. And thank you, everyone, for hosting us. So, Francois, exactly 1 year ago, welcome back to MIT. Exactly 1 year ago, we were here on the Arc Prize University Tour.
Yeah, it's been a while.
We were here promoting Arc Prize, Arc AGI. One of our main goals was to sort of inspire folks to work on new ideas towards AGI. And I think, we have our own. And one of the big updates since last year was, as Josh alluded to, we created our own intelligence science lab. It's called India. And we also are using Arc as one of our North Star metrics. I think to get there, we're trying to build the top program synthesis talent team industry right now. I think we've got a claim that we've got some of those folks. By the way, we are hiring. So if you're a builder and you're interested in program synthesis, you should come talk to us. But we're starting to make real progress over the last few months, I think, sort of some of the ideas we have, merging deep learning and program synthesis together towards Arc 1 and Arc 2. And hopefully sometime soon we'll start looking at V3. This question that Greg asked, I think, is a really common one that we got with V1 and V2 a lot. I'm curious to get your take here with V3, which is that, okay, you guys have now three versions of the benchmark. They all have AGI in the name. If we can make progress and we can beat V1, V2, and V3 here, do we have AGI? And if not, if that's not a binary, what does it mean exactly? Can you help us kind of map out what does it mean to make progress against Arc 1, 2, and 3?
Right. So first of all, as Greg stated, with V3, just like with V1 and V2, we are not making the claim that this is an acid test for whether we have AGI or not. Like solving V1, solving V2, solving V3 does not necessarily mean, it's not sufficient condition to say that we have AGI. That's not the purpose of the benchmark. Now, if you look at what it would take to solve V3, especially compared to V1 and V2, we're adding a few really important abilities. We're adding the ability to discover goals, like acquire your own goals from your own experience, do temporal planning, and of course, interactive learning. With V1, V2, you are just doing passive model feeding. You are looking at the data, trying to come up with a model to explain it. Here, you have to collect your own data by interacting with the environment. So what it would mean to create a system that could do these things at human level information efficiency, human level action efficiency, well, it means you're really good at agentic interactive learning in novel environments, you're really efficient at it. To me, that's basically a micro AGI. These are the properties you would want to see in an AGI system, but on a very small scale. So why very small scale? Because these games are really simple. They're really easy. Like any one of you in this room could just go and play them and you would do really well, right? It doesn't take, super intelligence. And they're also, just in terms of complexity size, like bit count, these are tiny games, right? So very small environments, very small perceptual space, and you're playing them on very short time scales, like you're learning across a few minutes. But of course, as a human level general intelligence, you're actually learning throughout your entire life with an enormous perceptual space. And you're learning tasks that are incredibly complex. So there's a very, very long distance from these sort of micro environments to the real world. But the properties we're trying to measure are the same. Like, can you efficiently interact with the world, discover its underlying principles, and make sense of it and act on it, shape it? It's the same principles, but on a tiny scale. So the idea is that if you manage to crack Arc 3 the right way, with an efficient system, without taking a shortcut, without brute force, ideally your solution can be just scaled up and you would get something very similar to AGI. But the solution itself would not be instantly AGI, or at the very least it would not be human level.
There's this big debate going on right now on Twitter, inspired by Rich Sutton's interview with Dwarkesh that got published this week, on whether LLMs are sufficient as a substrate to produce AGI, or at least systems that look like humans. I'm curious your take. Do you think that LLMs are sufficient as a substrate in order to do lifelong continual learning, like you just said, in order to beat V3?
I would say LLMs alone, definitely not. An LLM is basically a way to acquire and encode programs. It's basically a repository for a bunch of reusable vector programs. And the way you acquire them is via gradient descent on human data, right? And that's not what AGI is. It could be a component of AGI. I think it could be the sort of memory component, the knowledge and skill representation component. But the defining characteristic of general intelligence is how efficiently you acquire your skills and your knowledge. So basically, how efficiently you extract information from the world, from your experience, and turn it into these programs that should generalize as well as possible. And that's not what LLMs do. I mean, in the LLM world, the algorithm that's playing this role is just gradient descent. And gradient descent is, 4, maybe 5 orders of magnitude less efficient than human intelligence at skill acquisition. So this is not what you're looking for. So LLMs could be part of the solution, but they are definitely not on their own the solution.
There was another really common thing when we launched ArcPrize last year. A very common point of critique or feedback was the reason we haven't really made progress, LLMs haven't made progress on Arc is because it's a visual benchmark. You need some sort of visual progress in order to make progress. I think there's pretty strong evidence now that's not the case given sort of the reasoning models in sort of December. Curious how you look at V3, though. Do you think that we need sort of more advancements or breakthroughs towards the perception side in order to beat V3, or is this still fundamentally a program synthesis benchmark in your eyes?
Yeah, I think it's fundamentally a reasoning benchmark. It's not a visual perception benchmark at all. In fact, it was designed this way, just like V1 and V2. We were trying to remove the need for perception because perception was sort of like getting in the way of measuring what we cared about, which was efficient generalization, effectively efficient skill acquisition. In V1, V2, and even V3, the data, like the game state, is already in a format that can be processed by a computer. Like it's already effectively in token form. You can put it in an LLM. You can put it in a program synthesis engine, just like we do. There's no need for a vision module. And what we saw on V1, V2, and I'm sure we are going to keep seeing the same pattern on V3 as well, is that vision-enabled models, like VLMs, did actually significantly worse than pure sequence, like text models. And the reason why is really because you can treat like these 2D grids as sequences and you're not really losing any information, it's the same information. Now, if you wanted to have a native understanding of 2D space, you can also rewire a transformer to give it a native understanding of grids instead of sequences. Of course, if you do that, you would have to pre-train it on grid data, which is not widely available, so it will not work very well. And in practice, all the state-of-the-art models we're seeing on Arc V1, V2, they're pure sequence models, usually trained on code and so on. So yeah, it's definitely not a perception problem at all. And perception is not an obstacle to make real progress in these benchmarks.
Related to that, a lot of the solutions ArcPrize 2024 really relied on a lot of data augmentation techniques. Do you think that is going to be an important thing in order to solve V3 as well, is to take these and do lots of games that look like V3 in order to beat it?
I don't think so. And in practice, if you look at humans who have played a lot of games, they might be doing a little bit better than other people on these games, but it's not a lot. And even people who don't play games at all can still beat these games, right? They can still get grok how they work. And so that tells you that it's not really a matter of practicing. It's not a benchmark that's measuring an acquired skill. It's really measuring your ability to figure out something new on your own, interactively, on the fly.
Since we've been talking about the game design, let's switch over because I think this is one of my favorite parts of my job right now. Is every Wednesday for a few hours we get to play games and give feedback. It's a little grueling sometimes. Not all the games are good yet, but yeah, literally, we're sort of paid to play games. I think collectively we've probably played over 100 of them and given feedback. Do you want to talk a little bit about some of the common feedback we're finding and sort of playing these early preview games and giving feedback to the game design team?
Yeah, we have the most productive game design studio in the world. It's already over 100 games in less than a year. So it's actually very fun, making games, small games at scale and playtesting them, because you start really thinking deep about things like what makes a game fun. For instance, you try to come up with a theory of fun, to reverse engineer what makes a good game. So one thing we've observed is the most fun you're having is when the environment is trying to maximize the rate at which you're learning. In order to be fun, the game should offer some kind of challenge, right? It should be something you have to figure out, something you cannot already do. If you just recognize what you have to do and you do it, then it's very boring. It's very repetitive. You're just in execution mode. So it should have some kind of challenge, some kind of a novelty element. It should surprise you in some way. But at the same time, it should be tractable. It should not be too challenging or too novel, because then you would just get stuck. You'd not be able to make sense of it. So for the game to be really fun, you need to keep your learning rate in this sweet spot where it's challenging, but just to the right amount. It's challenging enough that you overcome the challenge and you learn in the process and you grow in the process. And establishing this sense of progression, of growth, is also very important. And it's not just in polishing your skill at playing the game, it's also that the game itself should, directly convey a sense of progression, like, for instance, affordance progression. As you play the game, you should be getting more powerful in some way. You should, have more things you can do, more actions. And the way you would do it is, you introduce new game dynamics as the game goes on, and you don't master them, and then you use them, and it opens up, new possibilities in the later levels. So yeah, I think this is really like the essence of fun. It's to maximize your learning rate and create this sense of growth and progression. Another thing that's interesting is how challenging it is to make games like this that are still easy to play for humans, given that we're in a setting where there are no instructions whatsoever, you're not told anything. In fact, there's also like no text, for instance, no text labels in the games and so on. You cannot leverage any acquired knowledge to play them. They're completely new. You can only bring to the games like core knowledge priors. And it's very easy to end up with games that are too difficult. Not too difficult because the game mechanics are too complex, but just because they're not learnable enough. And we had to put a lot of work into, really deliberately crafting the early levels of a game to make it as learnable as possible, like only introducing one concept at a time, making sure the controls are discoverable. One issue we had early on is players would often, fail to complete the game, not because they could not, understand it, because they could not discover the controls, right? They would try the arrow keys, for instance, would not do anything. And because it was a game where you were supposed to click on things, and they would never try to click on things. So we had to iterate a lot on the control UI, and we ended up with something that's a lot more discoverable.
In a lot of my user testing, I think there's an interesting tension here between easy for humans, hard for AI, and this concept of fun. Some of the most fun that I've heard from folks and myself is playing games where it's not immediately obvious until you explore a little bit, and then there's an aha moment. And that aha moment actually significantly increases your fun. So this sweet spot between not being too obvious on the level one, but still within sort of easy discovery, I think in the first couple levels.
Yeah.
Maybe why do we care about Arc being fun? This was a very unique design goal. I think you had in mind for V1 and V2 as well. Most benchmarks don't, especially AI benchmarks, don't optimize for fun. Why is this an important thing that Arc has this, like in the acceptance criteria?
I think on a very basic way, the benchmark will be more successful if it's fun, if it's catchy, if people actually enjoy interacting with it, enjoy playing the games. It will catch on. More people will be attracted to it. More people will want to work on it.
It's a human story, like it's inspiring.
Exactly. It needs to be catchy as a cultural artifact, not just as a scientific artifact. And also, I think that in order to make progress towards AGI, we need to do a lot of thinking about how humans play these games. And in order to get this data, like the human testing data, for instance, or just your own human introspection, perception, like as you play the games, you ask how you're figuring things out, what's your strategy, you try to leverage metacognition to produce AGI insights. In order to do that, the games need to be fun. They should not be boring. If they're boring, you're not going to want to play them. And human testers, they're not going to give it their best.
All right, so last question, looking towards the future. So even beyond V3, we've already started having conversations about V4, V5, whatever, even at lunch today. What are your maybe like hopes and dreams for what's not captured on this slide? What are the other interesting things that you can envision that we might want to test for capabilities-wise in future AI systems?
Right, so I think V3 has basically the right ingredients, like on-the-fly learning, interactive learning, goal acquisition, but at a very small scale. So for instance, this sort of interactive learning is not really what you would call continual learning, because even though there is a curriculum in each game, it's at the scale of 5 minutes of play. And as humans, we are doing continual learning over decades. And so I think an obvious thing would just be to take the same ingredients and scale them up, have much more complex environments, instead of just having 150 static games, have endless novelty, like have the game environment actually be more like a living thing, an intelligent thing with maybe other agents that you compete with, that you collaborate with. And we should try to measure the development of an agent not over 5 minutes, but over years of game time, hopefully not real time, right? And I think in order to build an environment that would be this ambitious, you kind of need to already be making progress towards AGI, because such an environment, it would be an environment that actually adapts to the player as the player adapts to the environment. as the player learns to play the game and interact with the agents that inhabit the game and so on. And so that is an intelligent artifact that is already a proto-AGI. And I'm a big believer in co-evolving the solution, like AGI itself, and the benchmark that you're using as your target. And I think progress towards AGI will help us create this next generation benchmark that will in turn help us make faster progress towards higher levels of AGI.
Great. All right. Well, while we're getting set up for the first speaker, let's do 2 questions. Maybe we'll do one from this side of the room and one from this side of the room. Is there a microphone you want to pass down?
I haven't looked at all the games available, but they're all, in a way, 2D, and the state can be frozen between turns, essentially. Does the intelligence or the learning acquisition skills, would you expect them to translate to a 3D environment or in a game where you don't have this sequence of turns, but it's rather a little more fluid, or maybe there's a physics engine that is a little more continuous in time?
Right, so the fact that the game frame is a grid of pixel is not really important. You could treat it as a sequence. It could be 3D, it could be 4D. It fundamentally doesn't matter. It's just a set of discrete symbols with discrete properties. They just happen to be organized as a 2D grid. It's fundamentally not important. So what you bring up, though, about the fact that this is effectively step-by-state environment where you have to take an action to get in the next state, that's definitely super different from like real-time continuous environment. I do think, yeah, if you make a really good V3 solver, you could put it on a robot, in principle. It's not the only thing you would need, right? You would also need a perception system to, this continuous live data into higher-level discrete concepts that the ARC solver could process. You would also need probably a longer-term sort of like planning engine to make use of the model produced by the ARC solver. But fundamentally, I think, you would be making progress towards real-world applications.
This was a really intentional design choice, right, for V3 as well, not to stress test perception, but to challenge the reasoning aspect of it.
We deliberately did not want games where time gaps were an element of gameplay, because we are not trying to, for instance, there are many games that are challenging for humans, not through understanding what's going on in the game, but just through execution difficulty, like timing difficulty, for instance. And we deliberately did not want to get into that because it's actually not intelligence.
Cool. One more question over here.
This is great. I'm really glad you guys are doing this. I have a really broad conceptual question. What is the distribution of skills over which you expect an intelligent agent to generalize?
Distribution of skills as in the kind of abilities?
Yeah, so you said skill acquisition efficiency. That's your definition of intelligence. And so you've built some set of games, right? And then you have test games. And you want an intelligent agent to generalize to those test games, right? So what is the distribution that is implied by that test set that you want to generalize over?
Implicitly, there is no distribution. Like for ArcV1 and ArcV2, what makes a valid ARC task is that humans can solve it. That's the only constraint that we have. And it should not leverage any acquired knowledge, only core knowledge. So anything you can build with only core knowledge that a human can do is in distribution. And there's no other more narrow definition of our distribution.
So the definition of the distribution is the set of things, or the distribution of tasks that humans can solve efficiently. Is that correct?
Yeah, which is basically infinite.
Okay, but it's not a uniform distribution over all possible tasks. I guess what I'm driving at is, what do you mean exactly by general intelligence, right? Because it sounds like what you're defining is actually human intelligence, not general
that's right, because this is, human intelligence is the only proof of existence we have of a GI.
But what is general about human intelligence? Human intelligence is not general. I mean, you could actually argue on the basis of no free lunch that there's no such thing as general intelligence.
It's general in the sense that when we are showing human testers any of these games, they are looking at the game for the very first time, and they can't figure it out. And the space of games you could give them that they could figure out is infinite and extremely diverse. So it's general in that sense. It may not be universal. I'm sure there are many tasks that you could show a human, and they could not figure it out. But still, the space of tasks that they can't figure out is vastly larger than what Frontier can.
We actually have existence proofs of that too with V2. We made tasks in V2 that were too hard for humans.
Right. So it's big, but it's not general in the sense that it can do anything.
So we are not targeting universal intelligence, which would be any task whatsoever. Yeah, we are targeting human general intelligence. That's right.
All right, let's wrap up there. Thank you, Francois.
Thank you. Let's hear it for Mike and Francois.